One. All right, we're live.
All right.
Hey,
Great.
hey everyone, thanks for joining us at the Google Cloud Platform Online Meetup. This is show number 10, and today we will be discussing networking on GCP and all the difference it makes. So my name is Anthony Bouchon, and I'm a customer engineer here with Google, and I'm joined by David and Henry, and I'll let you guys introduce yourselves.
Yeah, good morning, Henry Ho. I am a customer engineer as well, and just joined Google about 4 months ago, a little over 4 months ago. Happy to be here with you guys today.
David?
This is where I say things. Oh, hello
Yes.
again, everyone. My name is David. I am still a customer engineer here at Google, and for some reason, I'm back on the show.
Well, we brought David on to actually give us a little bit of intro music, but I feel that
We hit the button too fast.
we hit the button too fast. It's all good. Tune in to show number 11 for the music.
We're working on real music, but you know, life is hard.
Yeah, so I mean, I think that we have some excellent content today. I think if you're in the chat, let us know if the sound quality is good, if you can hear us, and also feel free to ask us questions as we move along. Again, this is very casual. We are here to just bring about awareness in the community, and so today's topic will be networking. And the man, the myth, the legend, Henry Ho, will be joining us. And I feel that as I wrote your intro, I was hyping you up. So I think everyone who's in attendance is very excited to see what you have ready for them.
All right, thank you, Anthony. And as Anthony mentioned, feel free to ask questions, guys. You guys on the forum here. We want this to be as interactive as we can, and hopefully this session is going to present some good information for you. So by way of introduction, I have been doing networking for more years than I would like to admit. So the giveaway here is my CCIE number 11184. So yeah, I have been a network engineer for a while, but I'm fairly new to Google Cloud and also new to Google Cloud networking. What I want to share with you today is what I've learned in the past 4.5 months, and also maybe a perspective from a network engineer's perspective, looking from the outside in. How is the Google Cloud Network different than the other cloud providers, and how is it different from a traditional carrier or an enterprise network? So hopefully that is going to be the main focus for the next 45, 50, 55 minutes.
You know, I was just thinking one day, Henry, when you've been with Google for 20 years and you know, I mean, you're pointing at your CCIE number there, 11184. Now you're going to point to Cloud Architect number 44. So
yeah,
I look forward to that day.
It's really great to have an early start, you know, with the Google Cloud. So it's my honor and privilege to be here today. So, all right, let's jump onto networking agenda. First thing I want to highlight is our global network topology and the footprint and the expansion of it. And then we'll jump into virtual private cloud, how we are doing virtual private cloud a little bit differently than the other cloud providers. And the third thing we're going to talk briefly into is our peering options. Now that you stand a VPC inside Google, how are you going to peer with your traditional network, with your on-premise network, and how do you make a hybrid cloud out of it? So that would be the main topics for today. But let's jump in. As I was learning Google networking, Google Cloud networking, there are many different projects along the way kind of compose this current state of the Google Cloud network. There's a lot of interesting projects, but I'm going to focus on a couple that we can share today and with a little bit more detail. First one is a software-defined load balancer. Load balancer takes a very important role of any network, right? It's usually the first ingestion point of customer traffic coming in. We use the load balancer extensively to balance all the incoming traffic from our back end to the front, from the front end to the back end, and also from the back end to various different tasks and processes. So the same fundamental load balancer is used to balance external traffic coming into Google Cloud and also internal traffic that needs to be balanced inside the data center. As you can see, in the cloud world, load balancing is usually one of the most important function. And started back in 2009, the load balancing function has been virtualized and distributed into many parts of the network. We'll show a little bit of that in a few slides and go into a little bit more detail. So load balancer is the first one. One I want to highlight is a software-defined wide area network, codenamed B4. Back in 2011, building a SD-WAN before SD-WAN was the trend. Basically, the fundamental there is the separation of control and data plane. Data plane is going to be our traditional MPLS network, but the control plane is logically centralized. Originally, it was based on OpenFlow, but since then, a lot of modification and addition has been put into the SD-WAN to make it a main source of traffic engineering tool for Google Cloud Network. Third component I want to highlight is a switching fabric called Jupiter. Jupiter is a 40 gig, 100 gig switch built from the ground up internally. So this is Google Switch. If you join us during our next show last month, you would have seen it on the San Francisco floor. So this is a switch that has 1,300 terabits per second backplane. And we use multiple Jupiter switches to build a data center fabric. Again, the keyword here is software defined. It's a SD data center switch, where we also do the separation of control plane and data plane, and control plane is virtualized and distributed and logically centralized.
And Henry, I know that people may be kind of interested in diving deep into the technology here. I know we published a research paper on maglev. Are there papers kind of diving deeper in B4 and Jupiter, kind of as a further reading for the audience?
Yeah, good point, Anthony. We actually have a white paper published. It's called Jupiter Rising, and it details the use of 40 gig and 100 gig in the switching fabric and how we build a quote-unquote virtual switch based on these components. Right. So certainly, if the audience is interested in further detail, we can certainly provide that white paper to dive deeper into what we do with Jupiter.
Right. And something else I want to call out too is that these things were not necessarily developed for Google Cloud Platform. I think you said maglev goes back to 2008, 2009. But these are things that were actually built for our own services that we provide globally, right? Like Gmail or search or whatnot.
Yeah, so from what I understand, more or less, we're using the same infrastructure for Google Map, Google Search, obviously YouTube and other Google properties, and now we're just adding cloud traffic on top of it. And to be honest, the rapid expansion of the Google Cloud Network is because of the additional Google Cloud traffic coming in. So certainly, we're sharing the infrastructure with the rest of the enterprises.
Got it.
All right, and the last component I want to highlight here before we dive deeper into the details is network virtualization. For the networking folks, this is also known as NFV, Network Function Virtualization. Basically, the load balancer, the firewall, the router, VPN gateways have all been virtualized, distributed. Some of that function goes into the Jupiter fabric, and some of the function actually go into the stack, the network stack of the individual instances. So our load balancer is distributed, our firewall is distributed, so we're not going into a choke point of the network. And we'll have more slides to go into a lot more detail, into a little bit more detail today, but here are the highlight of what we've been doing in networking, right? So it's not a project just started yesterday, it's been ongoing for the past decade. On top of the Google Cloud Network, we have different tool sets, toolboxes, right? Certainly a set of tools for us to create a global private space, especially for our enterprise customers, where we do a lot of network virtualization. connectivity and network security are really two sides of the same coin. You can't really have one without the other, right? So we provide a lot of security and control on top of the virtual connectivity. So those roles would those tools would include IAM roles, identity and access management, distributed firewalls, stateless access control lists, certainly a lot of logging and stack driver visibility. So on top of this network, you can certainly run multiple different services. I highlighted load balancing as one of them. We also do CDN, content distribution network, on top of the Google Cloud Network. And last but not least, other functions such as DNS can also be leveraged on top of the network infrastructure. I'm going to highlight more or less the VPC toolkits and the hybrid cloud toolkits, where we can use VPN or various types of interconnect to tie your cloud presence and your on-premise presence together to create a virtual private cloud for our enterprise customers. All right, let's start with the regions. A region is a collection of data center. What we are showing here is our current blueprint, footprint, and also the expansion plan for 2017 and 2018. You are seeing 6 green bubbles here. Each bubble is a region. For example, we have the West region, Oregon, the Central region, Iowa, and the East region in South Carolina. Each region has different numbers of data centers inside it. So in Iowa, we have 4 different zones or data centers inside this region. So today, if you create a virtual private cloud in a project on GCP, automatically you see network connectivity in all 7 regions around the globe. The plan here is to expand into 10 more regions by 2018. So basically every 2 months, we'll be adding 1 region onto the Google Cloud Network platform. The next 3 coming up is Netherlands, Montreal, and California, and that will be done the second quarter of 2017. How do you connect to all of these regions and data centers? That's where point of presence comes in. So currently there are over 100 different POPs, point of presence. You can peer with the Google Cloud. So these are co-location facilities like a core site or a Exodus, current name, and maybe a level 3, that type of carrier where we can actually do public peering. Peering meaning you will be getting routes from AS 15169, the Google AS, and then we'll be taking your route from your AS and do network peering from those point of presence locations.
Right, and I think that's pretty important to call out as far as where your traffic really is going. As far as, I think with other cloud providers, you're routing the public internet straight to the data centers. But here we have, and correct me if I'm wrong, Henry, keep me honest, but I think that the points of presence here really help you get onto our backbone and our fiber as quickly as possible. And
you're right. That's exactly right, Anthony. So what connects our data center to all the POPs is our own fiber plant. Basically, you're seeing the fiber on the blue line here on the map. All the regions are connected using our own fiber or our leased fiber, but basically we have a tremendous amount of bandwidth that we can leverage. When you peer with us at any one of these 100+ peering points, you will then be connected directly onto our backbone. We're not relying on the internet to carry your traffic from POP locations to your region, to your VPC. We're running all the traffic on the Google owned fiber. So today we have 20 different zones connected over to 100+ point of presence, everything running on top of our fiber. Last count is we have hundreds of thousands of miles of our own fiber connecting all these locations together. Rough estimate is that the capacity we have today can carry about 1/3 of the whole internet. Quick question for you guys here. I see a missing link. Do you guys see a missing link on the map? Yeah, it's right here.
If I was connecting the dots, I would have said this is pretty well connected, but I suppose that shows my ignorance here.
Right. iOS, this is actually not unique to us. There is no direct link between Mumbai and Dubai, and because it crosses Afghanistan, Iran, and a couple politically, I guess, interesting locations. So we don't have a direct link, and a lot of the global carriers don't really have a direct link between these two. So just a fun fact to point out, right? So, you know, it's not 100% fully connected around the globe yet. All right, enough on that. Let's talk a little bit about load balancing and CDN. We mentioned that there are 100 plus point of presence. Over 80 of those have our load balancing. So we distribute our global load balancer into 80 plus different locations for HTTP and HTTPS traffic. And when you do a DNS mapping, DNS lookup, your IP address mapping to a name is going to be present in 80 plus locations. So single IP address showing up in multiple different places, serving the customers at the closest location, is a uniqueness of our global load balancing option.
Henry, I feel like you just dropped the mic on us there. I just want to call that out. That's huge. I mean, as far as the concept of having this global load balancer with a single IP, and this single IP being present in over 80 points of presences. I mean, this is something that really does differentiate the concept of setting up a load balancer. As far as I know, that there are other cloud providers where maybe you set up a fleet and underneath it are VMs that ultimately are regional or very kind of sensitive
inside
to
the data center.
Exactly. So this is pretty cool.
There's that angle on it, and then I've also worked with customers in the past who are sort of on the edge of trying to figure out if they needed a CDN or not. But one of the things that they were able to do as they moved to GCP was to decide that that wasn't necessary at this point, because there are so many points of presence and it all goes straight to the fiber backbone, that they were getting performance that was acceptable in terms of what they were looking for, without having to sort of re-architect their application and start caching everything and worrying about that dynamic all over.
Got it. Very good point, David and Anthony. Right, and it seems simple. It's easy to understand one IP address showing up in multiple places, but implementing this is not trivial, right? What's under the hood is what we call Anycast, and any network engineer on the line here will understand that Anycast is not an easy protocol to deploy. And we have run it over the entire Google backbone. So from these 80 plus locations, we're running Anycast, providing a single unique IP address serving multiple locations in the world. Yep. So we're going to expand that into more than 80 plus locations. Hopefully, into the future, covering 100 plus. All the point of presence will have our load balancer presence. This is part of our expansion plan. And kind of wrapping things up in terms of the global footprint is the network topology, including our global cache edge nodes. I mentioned we have 20 zones or data centers, 7 regions expanding into 20 in the next 2 years. Our own fibers connecting all these point of presence locations. And what you're seeing on the map here, the yellow dots are actually our cache. These are Google servers, Google hardware and software located inside our partners network, carrier networks spread around the globe. Another little fun fact, Anthony, I'm going to call on you. How many countries do we have in this world?
Ooh, it's 190 something.
All right.
It's in the ballpark.
Good answer.
I did not just Google that. Oh, right. There's issues with what one may call, let's say, well, I won't call it out as far as, but yes, there are political tensions that confuse the definition.
Yeah, good point there. So 196 if you include Taiwan, 195 if you don't include Taiwan. That's where it stands. There it is. And if you look at our cache edge nodes, they are spread over 183 countries. So we're not as extensive as the United Nations, but we're pretty close. All right. So that is our network presence. This is the Google network. But what does that mean to our enterprise customers? How do we take advantage of this Google Cloud network that spans the globe? That's where VPC comes in. Great name, virtual private cloud, but from the network perspective, a VPC is not much more than a virtual network. And we'll drill down into a little exactly that means, right? So because our network is global in scope, every VPC that our customers create, when you sign up for a project, automatically you'll be getting a VPC, virtual private cloud, that is also global in scope. You can create additional VPC sharing across your organization if you have many different parts of the organization on the cloud platform and sharing resources. You can expand your VPC. Say you start with a /20 and you need to expand into a /23 or a /22. You can do it dynamically on the private cloud. Last but not least, you can leverage private RFC 1918 addresses from the VPC to access Google services without using public addresses or traversing the internet. Let's dive a little bit deeper into the VPC structure. You sign up for a project, automatically you'll be given a global VPC. In a traditional environment, traditional cloud environment, VPCs are regional in scope. For example, if you create a VPC in US West, it's only limited in US West. Same for a different other region, US East, for example. If you want to connect your VPCs together, you either have to go through a VPN tunnel, building a VPN connection, or you do VPC peering. Peering, as far as I can tell, it's still non-transitive. So if you have 3 or more VPCs that you need to peer together in a traditional way, you have to create a mesh. So quite a bit of administrative networking work you have to do to stitch your VPCs together. That is not the case on the Google platform because we have designed the network to be global in scope from day one. The VPCs we provide our customers are also global in nature. So if you create a project in US West and later on expand that project into different regions, your network connectivity is there. Nothing more needs to be done. Rather than showing you on PowerPoint slides, let me show you in the console what a VPC and virtual network looks like inside GCP. So here is my GCP platform, and I'm looking at a freshly created project I call EHO Online Meetup. This is pristine. There's nothing that has been done on it. I just created a project from scratch, and I haven't really touched it since then. If you go into our menu and look at networking, just on a pristine project, automatically you have a network that spans into 7 regions. I mentioned earlier on the map that we're currently having 7 active regions, 3 in the US, Central, East, West, 1 in Europe right now, and 3 in Asia, East, Northeast, and Southeast. So all of these is created automatically for you. All the IP address range are provided. Default gateway per region is provided. Default firewall rule sets are also created for you. If you click on to the network name, you see the details, the addressing schemes, each region, firewall rules allowing ICMP incoming traffic, firewall rules allowing all internal machines to talk to each other, and also allowing RTP and SSH traffic. These are created automatically without any administrative administrative work required. You can click on a firewall rule that is predefined and say, I don't want it. I don't want RDP traffic to be coming in by default. You can just click that. Or you can add additional firewall rules on top of the pre-created one pretty easily. One more thing I want to show is the routing table. This would be equivalent to a show IP route on a traditional router. You see the 7 directly connected routes. and also a default. So think of it as a global virtual router that has 8 interfaces. 7 of those are directly connected into the subnets that your VPC owns, and 1 to get from the VPC outside to the outside world. Now, I'm going to show you another project that I use for my playing around inside GCP. So this is a sandbox project I created for myself. Vault network created in it. This one was created for me automatically when I create my project. On top of it, I also added my own network. It's a custom network rather than a automatically generated network. And in this custom network, I only have 2 segments or 2 subnets, one in Europe and one in US West. And I can create my own addressing schemes here, showing different subnet options I can pick and choose from RFC 1918. And the last network I want to show you is what we call a legacy network. If you still have applications that needs a flat network, it's probably not a very good idea nowadays, but if you do have that requirement, we can still create a legacy network on GCP to support your application. It's done through a command line, not from the GUI, but you can create a flat network that spans the globe. In my case here, I have a 172.16.00/12 spanning the whole globe in one flat layer 2 segment. So it shows you the ability and the flexibility of what we can create in terms of cloud networking, which is the backbone of a cloud VPC. So traditional network, automatically created network, custom network, and legacy network, all 3 types are supported right from the get-go in your VPC. Now, let's jump back into the slides, and I want to show you how you can connect into the VPC you just created that spans the globe. And that's where peering comes in. As a way for us to help you build a hybrid cloud. And more than likely, when you have a project instantiated inside GCP, you have your custom VMs in there, your customer instances, traffic serving instances. More than likely, for larger enterprises, there is a need to connect that cloud environment back to your on-premise. Maybe it's for a hybrid cloud deployment so that you can connect to multiple different clouds. Maybe it is for a hybrid application where you have the front end in the cloud, and maybe the back end database still running on premise for stateful control. And whatever the reason is, there needs to be a way for us to peer the 2 environments together. Step through several ways for us to do the peering from on-premise to the cloud. I'll start with the traditional way of direct peering. Direct peering is where we would meet together in one of those 100+ POP locations, and we do a traditional BGP peer with public ASN number. You would peer using your ASN, public ASN, to Google 15169, and we will do a network peer, become network equals. We share the routes with you through advertisements, and we install routes from you via your advertisements. So this is a very traditional ISP network operator type of peering that we can connect at a direct peering point. For direct peering, you need to have your own AS number. You need to have your own public address space. Not all the customers have access to those, right? So if you don't have your own ASN number, or public routable subnets or addresses, you can go through a carrier. A carrier is already, almost all the carriers are already peered directly with Google. And you can then lease a portion of the carrier network or connectivity from that carrier onto your premise, and therefore not have to peer directly with us. For both and carrier interconnect, we are talking about public peering. And therefore, over that peer link, if you want to access your cloud instances, cloud resources, you need to use a public address. Well, okay, not all enterprises want to use public address for communication in a hybrid cloud environment or a front-end, back-end environment. If you want to use RFC 1918 addresses inside the cloud through direct peering or carrier interconnect, we have to build a VPN tunnel on top of it. Most common and most cost-effective way to do it. slide after we cover VPN. So VPN will give you about 3 gigabits per second throughput per tunnel. And you can have multiple tunnels and do ECMP, equal cost multi-path, so that you can carry multiple gigabit of VPN traffic over public peering or carrier interconnect. The benefit of peering is because of the less number of hops between Google and your on-premise, the connection is more secure, it's more dedicated, you have fewer hops to cross, and it's easier to deploy security policy on a direct peering link. Higher performance, right? We can connect at a higher bandwidth, lower latency link, because what we are dealing with is cross connects inside collocations. And probably the most important reason is if we are peering directly, we don't have to rely on a carrier to send traffic back to you, our customer. We don't have to pay the carrier for that leg. We can then reduce the amount of egress costs for our customers, kind of share the savings. A lot of the customers peer with us publicly to get to the lower egress costs because the public peering is free of charge. We have heard loud and clear from multiple customers saying that peering using public addresses is probably not the most ideal way for enterprise type of hybrid cloud deployment. So in May, in next month, we'll be coming up with a new offering for Cloud Interconnect for us to peer privately customers directly through private interconnect or through our partners through partner interconnect. These type of peering, is directly equivalent to a direct connect on AWS. It is a private RFC 1918 to internal addresses on premise. So no VPN tunnel is required, no encryption, decryption required. It is a pure network cross-connect collocation type of peering. It makes hybrid cloud deployment a little bit easier, and it's actually a highly requested feature on Google Cloud Network. This is how it works. Connecting directly into your cloud VPC from the customer on-premise router through a colocation facility. This link in between is just a typical 10 gigabit Ethernet carrying multiple VLANs for multiple projects and multiple VRF supports back into the on-premise data center. But the peering is simple. It's a cross-connect in a colocation where we can meet our Google Peering Edge device can meet with the peering router directly with the customer. We will do the BGP peering. I'll show the BGP peering detail a little bit later on in a few minutes. Since you are peering your private cloud directly back to your on-premise, the whole Google network in between becomes a simple, logical layer 2 link. Any questions?
Looks
no. Okay,
like.
so let me jump. Go ahead.
Oh, sorry. No, I was going to say it looks like there's nothing in the chat, but as a friendly reminder, please do feel free to ask questions. Again, Henry's laying down a ton of knowledge for us, and me personally, I'm learning a lot from just from watching you present, Henry. I do have a quick question as far as the timeline for this. Is this something that this was recently announced at Next, or I think that you mentioned that there's a lot of customer demand for this. So what can we expect, or is there is that in the near future?
Yeah, good question, Anthony. Yes, it was announced in Next in March, and currently we're doing early access for some of the key customers. But in May, the target is mid-May, so we're talking about less than a month away. We will be rolling out this feature as an alpha product. So most of the customers will have access through the alpha program. And initially, we'll be using 10 gigabit links and multiple 10 gigabit links, up to 8 of those, to connect inside the colocation facility. Soon after our initial launch in May, we'll be providing 100 gig Ethernet as a peering option as well. Similar to carrier interconnect, right? If the customer for some reason can't really meet it in a local location, or they prefer to leverage one of their existing service provider for the peering, they can then just use a partner interconnect option to carry the traffic from their on-premise peering router through a service provider peering router to the Google Cloud. Again, we're talking about layer 2 carrier interconnect, cross-connect type of peering connections here. For some locations, for some geographies, the carrier may even provide a Metro E type of connections back to the customer network, and therefore the customer doesn't even need to peer with a router. So both L3 type of peering with the service provider, or Metro Ethernet type of L2 peering with the service provider will be available as options through the partner interconnect. For the network guys on the call here, let me jump a little bit more into the BGP peering portion, or the logical peering that is happening between this private peering connection. And we got quite a few questions on our alias from our customers. So I want to share this one slide with the networking folks online with us, just to clarify the mystery in between the connection. What we are peering together is two routers, a cloud router running inside and your on-premise peering router. So in this type of peering, you are not peering with 169. You are not peering directly with Google. You are peering with your own cloud router running inside your VPC in a private ASN number. So this provides the higher level of security that most of the enterprise customers are looking for in terms of a hybrid cloud deployment. What we do here is we logically create a VLAN between our peering edge and either your customer peering router or your carrier's peering router. And on that VLAN, there are only two endpoints: your router interface on premise and your virtual router interface inside your VPC. In this link, only link local addresses are supported. Here I'm showing the 169 10.1, 169 254 1.1 is used for peering purposes. And on this BGP peer, we would then advertise RFC 19 addresses into your premise, and subsequently your premise RFC 1918 addresses, private address space, back into your Google Cloud VPC. In essence, we're using this BGP peering to stitch the two pieces of the network together into a logically contiguous network. That's about as much detail I have prepared. Any questions from the online chat, Anthony?
Yeah, question I have is I did hear the term Metro Ethernet mentioned a few times by you. Do you want to, or at least for me, help me understand or get me familiar with that, what that is? And
yeah, sure thing, Anthony. Metro Ethernet is a pretty common offering from many of the carriers' service provider. Basically, if a customer has multiple locations they want to tie together, not in a traditional wide area network per se, but in more of a high performance Ethernet fashion, right? All I need is a layer 2 connection from point A to point B. I don't need to route in between if I can avoid it. So carriers usually provide a Metro Ethernet type of connection options over MPLS. The more technical term, it's Ethernet over MPLS, right? So E over MPLS is the underneath technology. Metro Ethernet is the product offering that is very common in most of the service provider product portfolio.
Awesome. No, that's super helpful. And I think kind of the net of all of this that you reviewed is there are multiple options, as far as I think that one of the biggest topics around this past few months, is especially around Next, is how do we begin to I think that cloud has been particularly strong for cloud native companies that are just starting fresh in the cloud. And now Google is strengthening its story for enterprises that have been traditionally in their own data centers, right? And so, using cloud is not as simple as, let's say, just building a net new app, but it's having to take all these connection considerations into play, and how do you do that securely and plan this out? Because I think that around this, at least the customers that I've worked with migrating out of data centers, there's a lot of planning required around networking and reviewing these respective options. So I think that this presentation has been immensely helpful for people making that evaluation.
Yeah, good point, Anthony. Thank you. And even before I joined Google, I was working with quite a few of the more traditional enterprises doing hybrid cloud, private cloud, and then peering with multiple cloud providers. I've heard over and over multiple times from banks, insurance companies, financial institutions, and whatnot, the more traditional brick and mortar type of company want to have the flexibility and the portability of a hybrid cloud. Right. More than one CIO told me that they want to have a 2+2 strategy, 2 main primary internal data centers and 2 key cloud providers, right? So they can shift their workload from one to another in case they need some flexibility, negotiation power, and whatnot, right? And to enable that type of a hybrid cloud, 2+2, you need to have good, strong peering relationship through the carrier or directly to your cloud providers. And our Cloud Interconnect provide that type of connection at high performance and low latency and also high security. So that is the purpose of these various types of options for customers to peer with us, and just to make sure they have the flexibility and they have the options.
Awesome. Well, I think that, at least everyone on this meetup, and last chance for any questions before we wrap up here. David, anything else you want to add?
All of the things that Henry have said are, to be perfectly frank, extremely sharp and magnanimous. The thing that I run into, I would say, the most as I'm working with clients who are coming on GCP is that it can be a real mind shift for that global VPC function is a big head change from most of the pain and administration that they expect to bring to the platform. So the idea that things are set up for you out of the box, or that it can be just as easy to add a machine in Europe, to add a machine in Asia, as it is to add a machine in the region that's closest to where your developers may be, is a huge mind change. And the peering options that we're offering that allow you to directly get access to that level of flexibility and that level of simplicity, to be perfectly frank, is one of the things that I find most exciting about some of the offerings that we have, is that we're bridging that simplicity gap so that you can literally do more with less overhead.
All right, very good point, David and Anthony. So just one last slide here to wrap things up for our conversation, right? So we're showing you again global network footprint. If you look at the upper left-hand corner, you see, kind of like some concentric circles. That's the way I like to see the Google Cloud Network. If you look at it, it's like a 3-tier, or at the core of the concentric circle is our regions and data centers. Currently, there are 20 zones and 7 regions. And then expanding out from that core is the 100+ point of presence locations, where we have CDN and global server load balancing enabled. And even extending beyond that is our cache nodes covering 183 countries. This is the global footprint of the Google network, and the way you interact with it is through the back end for the hybrid cloud, and also through our global load balancers in the front end, Anycast, so that all of your user traffic can be spread effectively around the globe, so that you're close, you're serving customers with the highest performance level. So as a network engineer, I see this as a very extensive, very built network. Underneath the hood, it's all MPLS, but we abstracted a lot of that complex technology with SD-WAN, so that the network is easy for folks to understand. And it doesn't happen overnight, right? This network took Google more than 12 years to build. So it is an evolution of the network. Originally built to serve Google, is now available to serve all the enterprise customers running on top of Google Cloud.
Yeah. Hey, Henry, we do have a quick question from the audience. Not quite off the hook yet.
Yes, sir.
Case from Girish, and excuse me if I'm butchering the pronunciation, but in case of peering via ISP, does MPLS tunnel terminate at the Google Cloud router?
So the peering we have with the carrier is just a simple layer 2 cross connect, right? The MPLS extension doesn't need to extend into the Google Cloud. Inside the carrier cloud and also inside the Google Cloud, MPLS is the underlying technology that stitches everything together with labels, right? But the peering relationship we have with the carrier and also the peering relationship we have with the larger enterprises is through traditional BGP.
Great. Thanks, Henry. Really appreciate it. I think that's it. I think that one thing I totally forgot to bring up, and I forget which talk I was watching, but I saw too that at one point we had to shark-proof our transoceanic cables. And I meant to send you, there's a GIF of it it's pretty funny to watch, but maybe next time.
You mean there's a GIF of it?
GIF. I mean,
it's a GIF. All right.
We can have a whole meetup on the debate of the pronunciation, David. You and I will have that one.
Okay.
All right. Thanks everyone for joining. Really appreciate it. We hope to see you next time. And thanks again, Henry.
Thanks. Later, guys. Thank you.
Thanks,
Bye-bye.
everyone.